Hello everybody, welcome into another lesson. So today we got a real treat for you. Today we are going to graph polar equations. And we're going to get some really cool shapes when we do these. Now, at first it's going to start off a little slow, but we'll progress into some really cool things. So let's start off with something simple where you have r equal to some number. In this case, r equals 5. If you ever have this, this is just a circle where the right hand side is your radius. So this is just a circle with radius 5. Notice an angle isn't specified, so this will be the entire polar plane will be radius 5. So it doesn't matter what angle you start with, just find the radius of 5 and draw a circle all the way around until you have a circle with radius of 5. So I'm just trying to draw this accurately here. And there is my circle with radius of 5. So if you ever just have r equals 5, that denotes a circle with radius 5. Or if I had r equals 7, that'd be a circle with radius 7. r equals 1, circle with radius of 1. Really, that's all. If you have r equal to some number, it doesn't specify an angle or anything, then it's just a circle with that radius. Alright, I think that one's pretty basic. Now, we also talked about before when we were doing equations, you might sometimes just have theta equal to some angle value. In this case, we'll do theta equals 5 pi over 3. So theta equals 5 pi over 3. And when we were converting polar equations to rectangular equations, we determined that this was a line. And that's exactly what you're going to get is a line. So let's find 5 pi over 3 on here. So 5 pi over 3 happens to be right here. So you always start at the origin, at the pole, draw the entire 5 pi over 3 axis. But you have to keep in mind, going this way is positive on the 5 pi over 3 axis. If you subtract pi from this, you'll go in the negative direction on the 5 pi over 3 axis. So really, you're also going to go into 2 pi over 3, and you'll have a whole line. So theta equals 5 pi over 3 is this line through the pole shading 2 pi over 3 and 5 pi over 3, because 2 pi over 3 is the negative direction for the axis 5 pi over 3. So that's just a line. Let's do one more with an angle, and then we'll start getting into the good stuff. Let's say I pick theta equals pi over 6. So I have theta equals pi over 6. So of course I'm going to start at the origin. Or at the pole I should say, and then draw through every radius of pi over 6. Because the radius isn't specified, this just turns out to be a line. Now, I also have to keep in mind I have to add pi to pi over 6, because that'll give me 7 pi over 6, which would be the negative direction for pi over 6, because a line goes both positive and negative. So I also need to actually draw through 7 pi over 6 to get the full line. So you would end up with a line that looks just like this for theta equals pi over 6. Alright, so we've drawn a basic circle, we've drawn lines, now let's get into what you're really here for today. We're just going to start with something really basic here. Let's say r equals 3 times the cosine of theta. So you have r equals 3 cosine of theta. Well, as we've determined, in the first example, that was a circle with the center at the origin. Now, when you have some coefficient on a cosine or a sine, that's a circle still, but the center's not at the origin. So what we have to do, we need to take our special angle values here and take the cosine of each one of those. We can skip the pi over 12 increments, just stick with your zeros, pi over 6, pi over 4, pi over 3, and pi over 2 increments. So what is the cosine of 0? Well, the cosine of 0 we know is going to be 1. Take that times 3, you'll be right here. So just plot your point there. Now, the next special angle is pi over 6. So if we take 3 times the cosine of pi over 6, what do we get? Well, the cosine of pi over 6 is the square root of 3 over 2, so you'll have 3 times the square root of 3 over 2, which would give you just that. Now, it might be helpful in this case to go ahead and get a decimal approximation so you know about where you're going to plot. Let's see what we can do here with a decimal approximation. So let's take 3 times the square root of 3. Let's divide that by 2. You get about 2.6. So at pi over 6, you're going to be about right there, 2.6. Now, my advice is, okay, what you want to do, once you start getting more than one point, connect your pre-existing points. So let's go ahead and start connecting our pre-existing points. All right, next special angle is pi over 4. So if I take 3 times the cosine of pi over 4, what would I end up getting? That would give me 3 times the quantity of the square root of 2 over 2, which in turn would end up giving me just that, 3 times the square root of 2 over 2. Let's get a decimal approximation for that. So let's see here. All right, 3 times the square root of 2 divided by 2 puts me at about 2.12. So I'm going to be roughly right there on my polar axis. Let's go ahead and connect the last point to the new point. So far I've connected all existing points. All right, the next special angle is pi over 3. So let's go ahead and do that. Well, so we're going to take 3 times the cosine of pi over 3. All right, well, what is the cosine of pi over 3? That's just 1/2, so 3 times 1/2 is 3/2, which we know to be exactly 1.5 in decimal form. So we would be right here for the polar coordinate. You'll have a coordinate of about 1.5. Now, next special angle is going to be all the way at pi over 2. Well, that should be easy. What is the cosine of pi over 2? That's 0, and 3 times 0 is 0. So pi over 2 will be at 0, which would put us at the pole. So there's all of our pre-existing points thus far. We have half the circle formed. Now let's go to 2 pi over 3. So let's say I put in 3 times the cosine of 2 pi over 3. Well, cosine, keep in mind, is going to be negative in the second quadrant. The cosine of pi over 3 is 1/2. If you negate that, you'll get negative 1/2. So you'd have 3 times negative 1/2, which would give you negative 3/2, which is exactly negative 1.5. So if you find 2 pi over 3 right here, you actually got to go in the negative direction, which would put you at 5 pi over 3 at 1.5 on the 5 pi over 3. So go ahead and connect what you have so far. All right. Now the next angle in this is going to end up being 3 pi over 4. So let's take 3 times the cosine of 3 pi over 4. So again, cosine's always negative in the second quadrant. The cosine of pi over 4 is the square root of the square root of 2 over 2. So this would be 3 times negative square root of 2 over 2, which would give me, indeed, negative 3 times the square root of 2 over 2, which should give me a decimal approximation here. If I go ahead and do that, that would put me at, let's see, so about negative 2.12. So I'm at 3 pi over 4, but I got to go in the negative direction, which would actually put me at 7 pi over 4. I end up getting about negative 2.12, so about right there. Let's connect what we have so far, and then let's go ahead and find the next special angle, which is 5 pi over 6. So let's take 3 times the cosine of 5 pi over 6. Alright, so 5 pi over 6 cosine is negative. Well, what's the cosine of pi over 6? That's the square root of 3 over 2, so we have to negate that. That would be 3 times negative square root of 3 over 2, which would end up giving me negative 3 times the square root of 3 over 2. So let's find the decimal approximation for all that. Alright, so let's go up here. That gives me about negative 2.6. So if I go negative 2.6 on the 5 pi over 6 direction, that would actually put me at 11 pi over 6. That'll put me about right there. So let's go ahead and connect what we have here. And then next special angle is pi. Well, the cosine of pi is negative 1. 3 times that would give you negative 3. So you'd actually end up back on the 0 or 2 pi axis. So just connect what you have here. Now, real quick, if we start taking the special angles, the cosine of 7 pi over 6, we know that's negative. That's going to put me back at pi over 6. We already have a value. If you do 5 pi over 4, that'll put me back at pi over 4, which we already have a value for that. Same with 4 pi over 3, that would put you back at pi over 3. 3 pi over 2 would put you back at pi over 2. We have a value there. Then if you did 5 pi over 3, that would put you positive. We already have a value. Same with 7 pi over 4 and 11 pi over 6. So the circle's completed. So if you have a cosine of theta, it's going to be symmetric with the polar axis, this is called, which is 0 through pi. That's called the polar axis. It has polar axis symmetry. Now, let's change the function a bit, and we'll see how this is different. What if I did 3 times the sine of theta? So this time we're doing 3 times the sine of theta. Well, let's go ahead and start doing this again. What is the sine of 0? That's just 0 times 3 is 0. So you'll actually start right at the pole this time. Okay. Next special angle is pi over 6. So if I take 3 times the sine of pi over 6, well, what is the sine of pi over 6? That's 1/2, so that would give me 3 times 1/2, which would just give me 3/2, which would give me 1.5. So I find if I find 1.5 on the pi over 6 axis, that's going to put me right there. So let's go ahead and start drawing what we have. There's pi over 6. Now let's go ahead to the next special angle. That's pi over 4. So if we do the sine of pi over 4, well, we know that's a square root of 2 over 2, so you'll have 3 times the square root of 2 over 2, which is just that, 3 times the square root of 2 over 2. Let's see what we get for a decimal approximation. You get about 2.12. So at pi over 4, you'll be up here at about 2.12. So let's go ahead and continue connecting. Okay, now next special angle is pi over 3. So 3 times the sine of pi over 3. Well, the sine of pi over 3 is the square root of 3 over 2. So you have 3 times the square root of 3 over 2, which is just that. 3 times the square root of 3 over 2 puts me at about 2.6. So that's going to put me right here, roughly. And then the next special angle after that is pi over 2. Well, what's the sine of pi over 2? That's 1. 1 times 3 is 3. So I would be at radius 3 for pi over 2. We'll connect that dot. And then now let's go around to these angles in the second quadrant. Next special angle is 2 pi over 3. So if I take 3 times the sine of 2 pi over 3, well, the sine is positive in the second quadrant. So that's like the sine of pi over 3. That's also the square root of 3 over 2. So you'll have 3 times the square root of 3 over 2, which is approximately equal to 2.6. So at 2 pi over 3, I'll be down to about 2.6, which is right there. Okay, next special angle is 3 pi over 4. So the sine of 3 pi over 4, again, that's positive in the second quadrant. So you would have 3 times the square root of 2 over 2. Well, square root of 2 over 2 times 3, that's approximately equal to 2.12. So that's going to put you down here for 3 pi over 4. Let's connect what we have here. And then 5 pi over 6 is the next special angle. So we have to take the sine of 5 pi over 6. Well, okay, what is the sine of 5 pi over 6? That's positive 1/2, so you'd have 3 times positive 1/2, which would give you 3/2. That would give you exactly 1.5. So positive 1.5 on the pi over 6 axis is 5 pi over 6 is right there. Then the next special angle after that is pi. Well, what's the sine of pi? That's just 0. 3 times 0 is 0. So we can connect everything here. And then if you start taking your special angles in the third quadrant, like 7 pi over 6, you would get a negative value, which would actually end up putting you on the positive pi over 6 axis. You already have a value there. If I do 3 pi over 2, that would give me a negative value, which would land me on the positive pi over 2 axis. So you see, if I keep going, I'm going to end up back where I was with points already plotted. So if you have a coefficient on a sine of theta, the sine is a circle also, but it's symmetric with the pi over 2 axis as opposed to the polar axis. It's got symmetry with the pi over 2 axis, but still a circle. Alright, I think we have had enough of circles. Let's get into some really fun shapes here. So let's do... Now this is going to change it a bit. What if I did 5 minus 5 sine of theta? Now, okay. You may be thinking, isn't this just going to be a circle? Actually, no, and you're about to see here in just a minute. If we were in the normal xy coordinate system, this would be the sine function reflected and shifted upward. It doesn't work that way when it comes to polar systems. Okay, so let's go ahead here again. Start with 0. There's no better place to start. Angle 0. Well, what is the sine of 0? That's just simply 0. But if you add that 5, you would get a radius of 5. So 1, 2, 3, 4, 5. So we're going to be right there. Okay, now next special angle is pi over 6. So if I take 5 minus 5 times the sine of pi over 6, well, what's the sine of pi over 6? That's 1/2, right? So we'll have 5 minus 5 times 1/2, which would give me 5 minus 5/2, which is the same as 10/2 minus 5/2, which would give me 5/2, which we know 5/2 is exactly equal to 2.5. So at pi over 6, we're all the way down to 2.5. Let's go ahead and connect what we've gotten so far. Okay, so next special angle is going to be pi over 4. So let's do 5 minus sine of 5 pi over 4. Okay, so what is the sine of pi over 4? Well, that's the square root of 2 over 2, so you'd have 5 minus 5 times the square root of 2 over 2, which then we should be able to get a decimal approximation. Now let's see, negative 5 times the square root of 2 divide that by 2, add 5 to that, you get about 1.46. So at pi over 4, you're just a little bit more than, you have a little bit less than half there. And yes, it is normal to get this type of curvature, but something really cool is going to happen. Okay, so next is pi over 3, right? So the next special angle is pi over 3, so 5 minus the sine of 5 minus 5 times the sine of 5 pi over 3. Well, what is the sine of what is the sine of pi over 3? That's the square root of 3 over 2, so you'd have 5 minus 5 times the square root of 3 over 2, which now we should be able to get yet another decimal approximation. So negative 5 times the square root of 3, divide that by 2, and then add 5 to that, you get about 0.67. So at pi over 3, you're about roughly right there. And then let's go to pi over 2. All right. I know this is a lot of plotting, and just like plotting rectangular graphs, you got to find points and plot. So what is the sine of pi over 2? Well, that's just going to be 1, so you would just have 5 minus 5, which is 0. So at pi over 2, you actually have a coordinate of 0 based on this. Now we start going into the second quadrant. So let's see here. So we've done pi over 2. Let's go ahead and do 2 pi over 3. So what is 5 minus 5 times the sine of 2 pi over 3? Actually, I think I drew that a little bit crooked here. I should have probably moved that up a little bit, because then, there we go. That's more what I should get. Polar graphs can be a bit tough. Okay. As far as like trying to plot it exactly, but the real cool thing's about to happen. So 2 pi over 3, well, that is positive, so that'd be 5 minus 5 times the square root of 3 over 2, which we had about 0.67. This would actually end up then going in the positive direction here. At 2 pi over 3, you're going to be about right there. So start connecting your points. Alright, so the next special angle is 3 pi over 4. So we're going to take 5 minus 5 times the sine of 3 pi over 4, which would end up giving you 5 minus 5 times the square root of 2 over 2, which should give us a decimal approximation. We should be at about 1.46, so at 3 pi over 4, we'll be about right there. So let's connect what we've gotten so far. And then let's go to 5 pi over 6. So 5 minus 5 times the sine of 5 pi over 6. Well, what is the sine of 5 pi over 6? That is, in fact, that's 1/2, so you'd have 5 minus 5 halves, which we know to be 2.5. That'd be 2.5. So we're going to go all the way up here for 5 pi over 6. Let's connect what we got there. Then the next special angle is pi. Well, sine of pi is 0. 5 minus 0 is 5. So 1, 2, 3, 4, 5 will be all the way over here. Starting to see that peak there. Look how cool this is. Wait till we get down here. It'll really start to come together. So the next special angle is 7 pi over 6. So we'll take 5 minus 5 times the sine of 7 pi over 6. Now we're in the third quadrant with 7 pi over 6. What does that mean? That means the sine's actually negative. So the sine of pi over 6 normally is 1/2, but you negate that, you would actually have 5 minus 5 times negative 1/2, which would actually give you 5 plus 5 halves, which would come to 7.5. So at 7 pi over 6, we're all the way to 7.5, which would put you right there. So let's go ahead and start connecting. Alright, now next special angle is 5 pi over 4. So we're going to have 5 minus 5 times the sine of 5 pi over 4. Well, okay, what is the sine of pi over 4? That's a square root of 2 over 2. If you negate that, since we're in the third quadrant, you would have 5 minus 5 times negative square root of 2 over 2, which would give you 5 plus 5 times the square root of 2 over 2, which now we should be able to get a decimal approximation. So 5 times the square root of 2 divided by 2 plus 5 would put you at about 8.54. So that's going to put you right about here. Let's continue connecting. Next special angle is going to be 4 pi over 3. So 4 pi over 3, well, again, it's going to be negative because we're in the third quadrant. So you would have 5 minus 5 times 4 pi over 3. The sine of that is going to be negative square root of 3 over 2, which would turn into 5 plus 5 times the square root of 3 over 2, which should give us another decimal approximation. Which puts us at about 9.33. So that's just a little bit over this here. And then next special angle is 3 pi over 2. Well, what's the sine of 3 pi over 2? That's actually negative 1. So 5 minus 5 times the sine of 3 pi over 2. That would give us 5 minus 5 times negative 1. Well, that's just going to give us 5 plus 5, which would give us 10. So we'll be about right there. And then we go to the fourth quadrant. And it's important we complete this. It is a lot of plotting and drawing. Okay, so let's do 5 pi over 3. 5 minus 5 times the sine of 5 pi over 3. It's going to be negative because we're in the fourth quadrant. Well, the sine of 5 pi over 3, this would put us at 5 minus 5 times negative square root of 3 over 2, which would put us at 5 plus 5 times the square root of 3 over 2, which was approximately equal to 9.33. So that's going to put us over here. Then we have 7 pi over 4. All right, so 7 pi over 4, that's going to be then negative square root of 2 over 2. So you'd have 5 minus 5 times negative square root of 2 over 2, which would give you 5 plus 5 times the square root of 2 divided by 2, which now we should be able to get a decimal approximation. That's about 8.54. So we get about 8.54, which is about right there. And then last special angle is 11 pi over 6. So if I did 5 minus 5 times the sine of 11 pi over 6, then what is the sine of 11 pi over 6? Well, that's negative 1/2, so this would be 5 minus 5 times negative 1/2, which would be 5 plus 5/2, which would just give me positive 7.5. So I'll be right here, 7.5. No, actually, that's right here. I'm sorry. I was way off. So connect those, and then at 2 pi, well, 2 pi is the same as 0, so we can just go ahead and close this out. And look what you got here. Doesn't this almost look like a heart or a pumpkin or something? Doesn't that look really cool? That is a shape. I'm going to write it for you. It is called a cardioid, in fact. That is what is called a cardioid, because it looks almost like a heart. Now, since the equation involved sine, it's symmetric again, notice, with pi over 2. Had this been 5 minus 5 cosine of theta, you would have also gotten a cardioid, but it would have been symmetric with the polar axis as opposed to pi over 2. So if you have some function where it's either sine or cosine of theta, no matter what the coefficient is, and then plus or minus some other number, you're going to get a cardioid. All right, let's move on to another one. I'm just this is really more of an artistic showcase of things you can do. If you were to try to do this with a cosine instead, you would get a very similar looking graph, only it would be shifted a little bit left or right. That's the only difference. All right, so let me relabel 3 pi over 2 right here. What's the next one I want to do? Actually, let's see here. So let's do 1 plus 4 cosine of theta. It's actually not going to be a cardioid, but it's going to be very interesting. Let's do this. So again, let's start at 0. So what is the cosine of 0? Well, that's 1. So you have 4 times 1 is 4 plus 1 is 5. So 1, 2, 3, 4, 5 when you're at 0. Next then is our special angle of pi over 6. So 1 plus 4 times the cosine of pi over 6. So what is the cosine of pi over 6? That's square root of 3 over 2, so you'd have 1 plus 4 times square root of 3 over 2, which would give you 1 plus 2 times the square root of 3, which should be able to give us a decimal approximation. That would get you at about 4.46. So 4.46 would put you roughly right there. So let's start connecting. All right, so next, special angle is pi over 4. We have 4 cosine of pi over 4. Well, cosine of pi over 4 is square root of 2 over 2. So this would turn into 1 plus 2 times the square root of 2. Let's get another decimal approximation. That would put you at about 3.83. So 1, 2, 3, that would put you about right there for pi over 4. All right, so next special angle, well, that's pi over 3. what's the cosine of pi over 3? That's just 1/2, so you'd have 1 plus 4 times a half, which we know to be 1 plus 2, which is 3. So at pi over 3, you'll be at exactly 3. Alright, so next special angle is going to be pi over 2. So what is the cosine of pi over 2? That's 0, plus that 1 will put you at 1. Alright, so next special angle is 2 pi over 3. Well, this time we've entered the second quadrant. Well, here's the thing. Cosine in the second quadrant is negative. What's the cosine of pi over 3 normally? It's 1/2, but we got to negate that, so you would end up having 1 plus 4 times negative 1/2, which would end up giving me 1 minus 2, which would give me a coordinate of negative 1. So at 2 pi over 3, I actually have a coordinate of negative 1, which would put me down at actually 5 pi over 3. So there's my negative 1 on the 2 pi over 3. Let's connect what we have so far. And then let's go ahead and deal next with 3 pi over 4. That's the next special angle, is 3 pi over 4. Well, again, that's going to be negative because we're in the second quadrant. So cosine of pi over 4 is square root of 2 over 2. So you'd end up having 1 plus 4 times negative square root of 2 over 2. Well, this would give me 1 minus 2 times the square root of 2, which now I should be able to get a decimal approximation. So negative 2 times the square root of 2 plus 1, that's about negative 1.83. So we go negative on the 3 pi over 4 axis. We're actually down in 7 pi over 4. So that's about negative 1.83. That's about right there. Connect what you have so far. I promise you this is not going to be another circle. No, not at all. Not at all. What about next is 5 pi over 6. So we have 1 plus 4 times the cosine of 5 pi over 6. Well, cosine is going to be negative since we're in the second quadrant. Alright, so cosine of normal pi over 6 is 1/2. So this would actually be, I'm sorry, that's square root of 3 over 2. I don't know why I was thinking of the sign. 5 pi over 6 then would be 1 plus 4 times negative square root of 3 over 2, which would be the same as 1 minus 2 times the square root of 3. Now we should be able to get a decimal approximation. Alright, so negative 2 times the square root of 3 plus 1 is about negative 2.46. Well, if I'm going in the negative direction on 5 pi over 6, that'll actually put me on the 11 pi over 6 axis. So I'm going to be about right there, about negative 2.46. Alright, now the next thing is pi. So what is the cosine of pi? Well, let's write this out here. So 1 plus 4 times the cosine of pi. Cosine of pi is negative 1. 4 times that is negative 4. So 1 minus 4 would give you negative 3. But if I go negative on the pi axis, I'm actually back on 0 or 2 pi, however you choose to look at it. So that would put me right here for a radius of 3. As you're beginning to see, this is not going to be a normal circle, not whatsoever. Alright, next we're in the third quadrant, so let's go to 7 pi over 6. So 1 plus 4 times the cosine of 7 pi over 6. Well, it's also negative cosine since we're in the third quadrant. Cosine of pi over 6 is normally square root of 3 over 2, so you'd end up having 1 plus 4 times negative square root of 3 over 2, which is the same as 1 minus 2 times the square root of 3. Let's get a decimal approximation for that. We know it's going to be negative. That's about negative 2.46. Negative 2.46, but if I go in the negative direction on 7 pi over 6, I'm back at pi over 6. So that would put me at negative, that would put me at positive 2.46 roughly on the pi over 6 axis. So let's close this in here. All right, next then is going to be 5 pi over 4. So if I do 1 plus 4 times the cosine of 5 pi over 4. We know the cosine will be negative due to the fact that we're in the third quadrant. So what's the cosine of pi over 4 normally? That's a square root of 2 over 2, so this would actually be 1 plus 4 times negative square root of 2 over 2, which is the same as 1 minus 2 times the square root of 2. Let's see what we get for a decimal. So negative square root of 2, negative 2 times the square root of 2 plus 1, that's about negative 1.83. But if I go backwards on the 5 pi over 4 axis in the negative, that puts me in the positive pi over 4 axis. So here's about negative 1.83 right there. Okay, so next then is going to be 4 pi over 3. Alright, so we have to deal with the cosine of 4 pi over 3. Well, what's normally the cosine of pi over 3? That's normally 1/2, but since we're in the third quadrant, it'll be negative. So we'll have 1 plus 4 times negative 1/2, which would give me 1 minus 2, or simply negative 1. If I go in the negative direction on 4 pi over 3, that'll put me on positive pi over 3 right here at the radius of 1. And then I next have 3 pi over 2. What's the cosine of 3 pi over 2? That's 0. So that would just give me then 1 plus 0 is in fact 1. So that's going to put me actually right here then. What a loop we just did. You're starting to see the shape of this thing by now. Then we just have the fourth quadrant. So next special angle is going to be 5 pi over 3. Well, in the fourth quadrant, the cosine is positive. So what's the cosine of 5 pi over 3? That's going to be positive 1/2, so we'd have 1 plus 4 times 1/2, which would end up being 1 plus 2, or simply 3. So at 5 pi over 3, go 1, 2, 3, we're right here. And then next special angle is 7 pi over 4. So cosine of 7 pi over 4, well, that's positive cosine in the fourth quadrant. This would be the same as 1 plus 4 times the square root of 2 over 2, which is 1 plus 2 times the square root of 2. Let's see what our decimal approximation gives us. So 2 times the square root of 2 plus 1, that's about 3.83. So that'll put you at about 3.83. So that'll put me about right there for 7 pi over 4. Next we have 11 pi over 6. So we have, what's the cosine of 11 pi over 6? Well, that's square root of 3 over 2. So this would be 1 plus 4 times the square root of 3 over 2. So that would equal 1 plus 2 times the square root of 3, and then we should be able to get a decimal approximation. That's about 4.46, so that's going to be about right there. And then we're back to 0 or 2 pi. When we get to 2 pi, we're back where we started. So there you go. Look at this graph. So it almost looks like a cardioid, but it's not. It looks somewhat like it, and it's related to a cardioid, but it's not called that. Look at the loop in here. Look at the loop, the way it looped around. Whenever you have a coefficient on a cosine plus or minus some number, you actually end up getting what is called a Limaçon. That is what's called a Limaçon, in this case with one loop. You could have more than one loop, you could have no loop, or part of a loop, but this is a Limaçon with one loop in this case. Alright. Let's go ahead now and do some others. Alright, so what if I did something like 6 times the cosine of 2 theta? All of a sudden, we don't just have single theta, we have a double angle. And this is really going to change what the graph looks like, actually. Well, 2 theta, this is where our pi over 12s are going to come into play. Because if you take 2 times pi over 12, that's the same thing as pi over 6, right? But wouldn't we also need a pi over 8? We're actually going to need a pi over 8 in this case. So let me draw a pi over 8. As straight as I can here. So there's my pi over 8. That means I need a 3 pi over 8. So let's see. So there's roughly 3 pi over 8. Alright, now, what about, let's see, we need some other pi over 8s. We need a 5 pi over 8. Here's going to be 5 pi over 8. Because you need to bring out that full pi over 4 value. Alright, so next then we need a 7 pi over 8, so let's see, so 1, 2, 3, 4. That's about right there. So here's my 7 pi over 8, and then next then let's get a 9 pi over 8, so let's see. So there's my 9 pi over 8. So that means next then I need a another pi over 8. So that would be then 11 pi over 8 I need to get. So here's going to be 11 pi over 8. Then I need to get a 13 pi over 8. So here's my 13 pi over 8. Then I need to get a 15 pi over 8. So yes, if you have other multiples of theta, you may have to draw extra axes that you didn't intend to, because you need to capture all of the special values in between. Okay, so we have every single special axis we can think of. Now, let's go ahead and start plotting. So let's start with 0. 2 times 0 is still 0. Cosine of 0 is 1 times 6, so 1, 2, 3, 4, 5, 6. There's my point there. Next then, our special angle, we're going to go right to pi over 12. So 6 times the cosine of 2 times pi over 12. Really, well, let's do that. So 2 times pi over 12. What does that give you then? That would end up giving you 6 times the cosine of pi over 6. Cosine of pi over 6 is the square root of 3 over 2. Well, that would end up giving you 3 times the square root of 3. Let's see what we get for an approximate decimal value here. So 3 times the square root of 3, that's about 5.2. So that's going to put you about right there. Let's go ahead and start making the connection. Then we're going to go to pi over 8. If you'll bear with me, I think you're going to like the shape we get. It's going to be really cool. So 6 times the 6 cosine of 2 times pi over 8. Well, 2 times pi over 8, that's just pi over 4. So what is the cosine of pi over 4? Well, that's a square root of 2 over 2, so 6 times the quantity of square root of 2 over 2 gives me 3 times the square root of 2, which let's see what we get now. Three times the square root of 2, that's going to be about 4.24. So that's going to put me about right there. All right, next angle then is pi over 6. Well, so let's put in pi over 6 for this angle. Well, what's 2 times pi over 6? Yeah, that's going to be pi over 3, so 6 times the cosine of pi over 3. That's going to give me 6 times 1/2, which would just give me 3. So at pi over 6, I'm going to be down to 3. See, even these small angles in between make a huge difference. All right, the next one's pi over 4. So the next angle, pi over 4, well, 2 times pi over 4, that's pi over 2. 6 times the cosine of pi over 2, well, that's just 6 times 0, which would give you a big fat 0. So at pi over 4, you actually are all the way at the pole. So let's connect that now. We're at pi over 4, which would be 0. And then let's do pi over 3. Now notice something. Since it's 6 times the cosine of 2 theta, this will be 6 times the cosine of 2 times pi over 3, which would be the same as 6 times the cosine of 2 pi over 3. So even though we're in the first quadrant, we're behaving like we're in the second quadrant. So 2 pi over 3, that cosine is negative 1/2. So we'll have 6 times negative 1/2, which would actually put us at negative 3. So for pi over 3, if we go in the negative direction, we'll actually be at 4 pi over 3. So 1, 2, 3. Let's connect those points. All right, so the next special angle then is going to be 3 pi over 8. Well, 2 times 3 pi over 8, that becomes 3 pi over 4. So cosine of 3 pi over 4, that's going to be negative square root of 2 over 2. 6 times that quantity gives me negative 3 times the square root of 2, which let's see what we get in terms of a decimal. That's about negative 4.24 when we're at 3 pi over 8. If I go in the negative direction, that'll put me at 11 pi over 8. So, let's see, 1, 2, 3, 4. So we're going to be all the way down here roughly. And then next special angle is going to end up being 5 pi over 12. Six times the cosine of 2 times 5 pi over 12. 2 times 5 pi over 12 turns into 5 pi over 6. So, okay, 6 times the cosine of 5 pi over 6, that's going to be 6 times negative square root of 3 over 2, which would give me negative 3 times the square root of 3. Let's see what we get for a decimal approximation. We get about negative 5.2. So in the negative direction, we'll go down to 17 pi over 12. So about negative 5.2, that's about right there. And then let's see what we get now when we go to pi over 2. Well, so 2 times pi over 2, as we know, that would be the same thing as 6 times the cosine of pi. Well, cosine of pi is negative 1. 6 times negative 1 is negative 6. So if we go negative on the pi over 2 axis, that puts us down at 3 pi over 2. Here's the 6. All right. Now, we finally start the second quadrant, 7 pi over 12. And again, this is just a lot of evaluating and plotting, but it's cool to show you what we can do here. So 2 times 7 pi over 12, that actually gives you 7 pi over 6. So 6 times the cosine of 7 pi over 6. Well, 7 pi over 6 is in the third quadrant, which would make this also negative. So you'd have 6 times negative square root of 3 over 2, which would be equal to negative 3 times the square root of 3, which, let's see, then we should just get, if it's 7 pi over 12, the negative of that would be down here at 19 pi over 12, about right there. Let's connect what we got so far. Then the next special angle should be 5 pi over 8. So what is 2 times 5 pi over 8? 2 times 5 pi over 8, that's 5 pi over 4. So this is going to behave as a third quadrant angle, which would give me 6 times negative square root of 2 over 2, which would be negative 3 times the square root of 2 over, negative 3 times the square root of 2, which negative on the 5 pi over 8 would put me down at 13 pi over 8, so about right there. And then the next special angle is going to be 2 pi over 3. So 2 times 2 pi over 3, well, that would give me 4 pi over 3, still acting as a third quadrant angle. The cosine of 4 pi over 3, that's negative 1/2. So 6 times negative 1/2 is negative 3. If we go negative on the 2 pi over 3, that'll put me down at 5 pi over 3. So here is my negative 3. And then we need to go to 3 pi over 4. So 2 times 3 pi over 4, well, 2 times 3 pi over 4, that's going to be 3 pi over 2. 6 times the cosine of 3 pi over 2, which is 0. So at 3 pi over 4, we're back to 0. Let's go ahead and connect what we have so far. Look how neat that is. We have a loop so far, and it's about to get even better as we head into... Next is 7 pi over 8. So if we do 2 times 7 pi over 8, well, what's 7 pi over 8 times 2? Well, that's just going to be 7 pi over 4. 6 times the cosine of 7 pi over 4. So though we are in the second quadrant, this is acting like a fourth quadrant angle. Cosine of 7 pi over 4 is positive. That would be 6 times the square root of 2 over 2, which would be positive 3 times the square root of 2. Let's see what we get for a decimal. That's about 4.24. So 7 pi over 8, so 1, 2, 3, 4, a little bit up here, right? And then let's go ahead now to, let's see, 11 pi over 12. Well, 2 times 11 pi over 12, that's 11 pi over 6. So 6 times the cosine of 11 pi over 6, that'd be 6 times 1/2, which would just be 3. So we're down to 3 right here. And then we have, let's see, what about pi? So pi, all right, so if we put in 2 times pi, what does that give me? Well, 2 times pi, that's just the cosine of 2 pi, which we know to be 1. 6 times 1 is 6. So we're actually going to get a positive here at pi. It's 11 pi over 12 is 11 pi over 6. I messed up here. It's easy to mess up on these too, I should tell you. Did I get off Keter a little bit? Forgive me. Yeah, 4.24, so why am I... Okay, 6 times 1/2 is 3. Hold on. See, this does sometimes, when you're drawing polar graphs, it can get very, very crazy. 5 pi over 6 was 5 pi over 3. I got that right. That's positive. 7 pi over 8, that's 7 pi over 4. So yeah, you would start going backwards then on the pi over 6. Okay. 2 pi then. Okay, so at 2 pi, yep, you would be at 6. And then at 13 pi over 12. Hold on, I want to retrace this. You see, if you're not careful, this can really throw you off. 7 pi over 4 was right. 7 pi over 8 was right. I don't think we did 5 pi over 6. You know what? It just occurred to me I skipped a value. That would explain it. See, it's easy to skip values. 2 times 5 pi over 6, so that's going to be 6 times the cosine of 5 pi over 3, which would end up being 6 times 1/2. Alright, that should give me 3. That's where I went off track. See, if you're not paying attention, this is actually a good teaching moment, because 5 pi over 6 would give you 3. There we go. That makes more sense. And then 7 pi over 8. Okay. So 2 times 7 pi over 8 is 7 pi over 4. Cosine of 7 pi over 4, that's 6 times the square root of 2 over 2, giving us 3 times the square root of 2. I knew something didn't look right. That gives me about 4.24. Right about there. That looks more like it. Okay, then 11 pi over 12. If I take 2 times that, that would end up giving me 6 times the cosine of 11 pi over 6, which is actually 6 times the square root of 3 over 2. Which would give you 3 times the square root of 3, which, let's see what the heck that decimal is. There we go. We're back on track. 5.2. Okay. So at 11 pi over 12, we're at 5.2. Now, what about pi? Well, so that would be like 2 pi. 6 times the cosine of 2 pi, that's 6. So, alright, there, we've completed another half loop. Now we actually get into the real third quadrant. Let's do 13 pi over 12. So we'll take 6 times the cosine of 13 pi over 12. Well, what is 2 times 13 pi over 12? That's 6 times the cosine of 13 pi over 6, which we know is over 2 pi. If you subtract 2 pi from that, you'll get something identical to 6 times the cosine of pi over 6, which then would give you 6 times the square root of 3 over 2, which would be, well, 3 times the square root of 3, which would put you a little bit over 5 again. So you're coming this way. Alright, now let's do 9 pi over 8. So I'm going to take 2 times 9 pi over 8. Well, 2 times 9 pi over 8, that would give me 6 times the cosine of 9 pi over 4. Well, 9 pi over 4 is over 2 pi, so subtract 2 pi, that would be the same as 6 times the cosine of pi over 4, which would give me 6 times the square root of 2 over 2, which would be 3 times the square root of 2, which would put me a little bit over 4. So then next I need to deal with 7 pi over 6. So take 2 times 7 pi over 6. Well, okay, so that would give me 2 times 7 pi over 6 is 7 pi over 3, which is over 2 pi. Subtract 2 pi, I would get 6 times the cosine of pi over 3, which is just 6 times 1/2, or 3. So at 7 pi over 6, you're down to 3. So next, let's do 5 pi over 4. Two times 5 pi over 4, that's 5 pi over 2, which would end up giving me same thing as 6 times the cosine of pi over 2, which we know to be 0. So 5 pi over 4 will be at 0. So we've just completed another loop. Now, let's go on ahead here and deal with 4 pi over 3, being the next special angle. So 4 pi over 3 is our next special angle here. Two times 4 pi over 3, well, that's 6 times the cosine of 8 pi over 3. Well, if we subtract 2 pi, that's going to give you then 6 times the cosine of 2 pi over 3, which will get us back to negative values. This would be 6 times negative 1/2, which would be negative 3. So we're on the 4 pi over 3 axis, but if we go negative of that, that's going to put us all the way up at pi over 3, which would end up being 1, 2, 3, will be right here. And then, let's see, we're going to do 11 pi over 8. So we have 2 times 11 pi over 8. Well, that would be the same thing as 11 pi over 4. If you subtract 2 pi, you'll get 3 pi over 4, which would be 6 times negative square root of 2 over 2. That's just going to give you negative 3 times the square root of 2. Let's see about where we end up. About negative 4.24 if we're on the 11 pi over 8 axis. Would we go negative, that'd put us on 3 pi over 8. So that's about right here. Let's go ahead and connect, and then next we're going to be at 17 pi over 12. So 2 times 17 pi over 12, well, that would end up giving us the same thing as 6 times the cosine of 17 pi over 6, which is going to be the same thing as 6 times the cosine of 5 pi over 6, which would be 6 times negative square root of 3 over 2, which would be negative 3 times the square root of 3. And let's see about where that puts us. So negative 3 times the square root of 3 is about negative 5.2, which would put me, if I went negative in 17 pi over 12 and the 5 pi over 12, so that's about right there. And then let's see, let's do next 3 pi over 2. So we're going to do 3 pi over 2. We're on the home stretch. We're getting ready to enter the 4th quadrant. I know it's been a long one, but 2 times 3 pi over 2, so that's 6 times the cosine of 3 pi, which is the same as 6 times the cosine of pi, which would just give me negative 6. So if I go negative on the 3 pi over 2 axis, I'm back on the pi over 2 axis at 6. And then let's see here, we're going to do 19 pi over 12. We're finally entering the 4th quadrant. So 2 times 19 pi over 12, well, that's going to end up then giving me 6 times the cosine of 19 pi over 6, which is the same thing as 6 times the cosine of, let's see, 7 pi over 6. Which would give me 6 times negative square root of 3 over 2, which would be negative 3 times the square root of 3, which should put me, if I go negative on the 19 pi over 12, I'll actually end up then on the 7 pi over 12. That would put me about right there. And then let's next do 13 pi over 8. So we have 2 times 13 pi over 8. If you take that, you'll get 6 times the cosine of 13 pi over 4, which is the same thing as 6 times the cosine of 5 pi over 4, which would be a negative value. You would have 6 times negative square root of 2 over 2, which would be negative 3 times the square root of 2. If you go in the negative direction for 13 pi over 8, you end up at 5 pi over 8. That would put me about right here. And then we need to do 5 pi over 3. So 2 times 5 pi over 3. Well, that would give me 6 times the cosine of 10 pi over 3, which 10 pi over 3 is the exact same thing as 4 pi over 3. Well, that would give me 6 times negative 1/2, which would be negative 3. So if we go negative on the 5 pi over 3, we'll end up on 2 pi over 3. So 1, 2, 3, that's right there. And then we need to do 7 pi over 4. So 2 times 7 pi over 4 would give me 7 pi over 2. So 6 times the cosine of 7 pi over 2 would be the same as 6 times the cosine of 3 pi over 2, which we know to be 0. So you'd be down to 0 right there. We're almost done. I think it's becoming obvious what shape we're going to get, but let's do the last bit of it. Let's close it out and show you how this works. So let's do 7 pi over 4. So 6 times the cosine of 2. No, we're actually on, sorry, 11 pi over 6. 2 times 11 pi over 6. That's going to give me 6 times the cosine of 11 pi over 3, which would give me 6 times the cosine of 5 pi over 3. Well, the cosine of 5 pi over 3, that's going to be positive 1/2, so 6 times 1/2 is 3. So we're going to be right there. And then let's see. We have next. Nope, I drew it wrong. It's 11 pi. There we go. All right. Next then, let's do 15 pi over 8. So 2 times 15 pi over 8. Well, that's going to be the same as 6 times the cosine of 15 pi over 4, which would end up being the same thing as 6 times the cosine of 7 pi over 4. So that'd be 6 times the square root of 2 over 2, which would end up being 3 times the square root of 2. Which would be about right there. All right, and then we need to do 23 pi over 12. I think we're about done, folks. So 2 times 23 pi over 12. Well, that's going to be 23 pi over 6. 6 times the cosine of 23 pi over 6, which would be the same as 6 times the cosine of 11 pi over 6. Well, that would end up then giving me 6 times the square root of 3 over 2, which would be 3 times the square root of 3. So that's going to put me about right there. I think I was off by 1 there. And then at 0, we'll be all the way back around. 2 pi, 4 pi, 0. So we're done. All that work just to get this, but it's kind of worth it. You got what's called a rose petal of 4 leaves. This is called a rose petal of 4 leaves. Now, I got one more. I know you're going to kill me, but I do have one more. Let's say let's see if I can make this a little bit easier. Well, I didn't erase my markers for that at least, thank God. So all right. At least I have my reference points now. where these pi over 8 angles were, right? Alright, so what about when we have something like this? So we have r squared equals nine cosine of 2 theta. R squared equals 9 cosine of 2 theta. So we're going to start again then with 0. Well, the cosine of 0, of course, is 1 times 9 is 9. So what we're going to have then is r squared would, if we do this, this is where it gets really cool. So if I take r squared, set that equal to 9 for my 0 angle, I get r equals both plus and minus 3, right? So actually I'm going to have two values. Here's a 3, here's a 3. Now we're going to build two branches simultaneously. So this actually isn't going to be quite as bad as you think. Now, what if I put in, let's put in pi over 12. So r squared would equal 9 times the cosine. What's 2 times pi over 12? That's pi over 6. Well, what is the cosine of pi over 6? That's square root of 3 over 2. So that'd be 9 times the square root of 3 over 2. So r would equal both plus and minus the square root of that 9 times the square root of 3 over 2. So let's see about where we end up. So let's see, 9 times the square root of 3 divided by 2. Now take the square root of that whole answer. You would get both plus and minus 2.79. So at pi over 12, you'll be at about plus and minus 2.79 right here. And then negative on pi over 12, well, that's actually going to be at 13 pi over 12. So that puts you about right there. Let's go ahead and start building this. We're building two branches at once, which is kind of nice. Let's do pi over 8. So if I take 2 times pi over 8, what does that give me? 2 times pi over 8, well, that's going to give me pi over 4. So 2 times, that would then end up giving me 9 times the square root of 2 over 2. So yes, 9 times the square root of 2 over 2, which means r has to equal both plus and minus that square root of 9 times the square root of 2 over 2, which I should be able to get approximate values then. So yeah, we actually have a square root inside of a square root. You get about negative 2.52, or positive and negative 2.52 for that pi over 8, which would be about right there. You do negative, you'll actually be at 9 pi over 8, so let's continue connecting. So next is pi over 6. Well, 2 times pi over 6, that's the same thing as pi over 3. Well, pi over 3, the cosine of that is 1/2, so that would give you 9/2. Well, that means r equals both plus and minus then. The square root of 9 is 3. That'd be 3 over the square root of 2, which would equal plus and minus 3 times the square root of 2 over 2. So then now we should be able to get our decimal place approximations. So 3 times the square root of 2 divided by 2, that's about positive and negative 2.12. So let's go ahead and plot that here. Pi over 6, you would have about 2.12 right there. And then if you go in the negative direction on pi over 6, you'll be at 7 pi over 6. Okay, so next is pi over 4. 2 times pi over 4. Well, let's do that here. So 2 times pi over 4, that's just pi over 2. The cosine of pi over 2 is 0. I think it's safe to say then that square root of 0 is in fact 0. So you'll get that actually for both branches here. You'll get a 0. Looks like a neat swirl so far, doesn't it? But we're not done yet. What if now here's the thing. If I start putting in any, actually no, I need to do pi over 3. Pi over 3 it's undefined for, because 2 times pi over 3, that's a negative. We can't take the square root of a negative. So we can't do 2 pi over 3. 3 pi over 8, that would be the same as the cosine of 3 pi over 4. That's negative. 5 pi over 12, that'd give you the cosine of 5 pi over 6. That's negative. You can't even do pi over 2, because then you would get the cosine of pi, which is negative. So we have to next go to 7 pi over 12. Well, that would give you the cosine of 7 pi over 6. That's negative. Do 5 pi over 8. That would give you the cosine of 5 pi over 4. Also negative. 2 pi over 3 times 2 is 4 pi over 3. Also negative. We can't do anything again until we get to 3 pi over 4. Because the 2 times 3 pi over 4 is the cosine of 3 pi over 2, which we know is 0. And we don't even have to move. It's just going to be 0. So now that we're back at 5 pi over 6, we should be in business. So 2 times 5 pi over 6, well, that's 5 pi over 3. Okay, well, the cosine of 5 pi over 3, that's going to be positive 1/2. So we're going to take, and let's just say that's 4.5. So r is going to equal plus and minus the square root of 4.5. So r is approximately equal to plus and minus. Let me take this. 4.5, that's approximately plus and minus 2.12. So at 5 pi over 6, let's go to, that's about 2.12. And then if we go in the negative direction, that'd be about negative 2.12, would put me at 7 pi. That'd actually put me rather at 11 pi over 6. And then let's go now to 7 pi over 8. 2 times 7 pi over 8 is 7 pi over 4. Well, cosine of 7 pi over 4, that's going to be square root of 2 over 2. So that's actually then going to equal, r would equal both plus and minus then the square root of 9 times the square root of 2 over 2. So let's go ahead and get our decimal approximations. You get approximately plus and minus 2.52. So we picked, what, 7 pi over 8. If you do the positive 2.52, you're about right there. If you do the negative, you're about right here on the 15 pi over 8 axis. And then now let's pick 11 pi over 12. 2 times 11 pi over 12 is 11 pi over 6. Alright, so 11 pi over 6, the cosine of that, that's going to be square root of 3 over 2. So that's just going to be 9 times the square root of 3 over 2 for what r squared is. Well, r would equal both plus and minus the square root of that 9 times the square root of 3 over 2. So now we should be able to get some decimals. Alright, so 9 times the square root of 3 divided by 2. Now take the square root of that. You get approximately plus and minus 2.79, which is even a little bit greater. In the negative direction, you would end up at 23 pi over 12. And then if you put in pi, well, cosine of 2 pi actually is going to be 1. 9 times that is 9. You get plus and minus the square root of 9. You get both plus and minus 3. So actually, we are back to where we started from. And there you go. It looks like we just graphed the infinity symbol. That shape, if you're wondering what it's called, is called a lemniscate. So this is what's called a lemniscate. You could think of it like skate, figure 8. You know, skaters in those shows do a lot of figure 8. So a lemniscate. You could think of it that way. Alright, so that's it for this lesson. Next lesson should be much shorter. It's going to be about eccentricity of conic sections, which will tie into the lesson after that, which is the polar equations of conic sections. So I hope everybody has a great day. Take care.